An important concept in trigonometry is the idea of reference angles. And the basic idea is that here I have a point, I have a unit circle, and the point 0.8 comma 0.6. And there are three other points that have as their sort of coordinates either 0.8 as their x, or negative 0.8 as its x coordinate, or 0.6 as its y, or negative 0.6 as its y. For instance, this point over here is basically reflected over the y-axis, so it's negative 0.8, comma 0.6. And this point over here is negative 0.8, negative 0.6, and this point over here is 0.8, comma negative 0.6. So these 4 points are kind of related in that they have kind of like the same x and y coordinates, just some might be negative, but 0.8 and 0.6 are sort of like the value, absolute value of the x and y coordinates. Here's the same picture, but here I have this angle identified as 37 degrees from here to here. And it's the same picture, those same 4 points, but the question is, what is the length of this, or what's the measure of this obtuse angle? Well, the trick to this question is to realize that if this angle here is 37, this angle over here would also be 37. It's like a reflection of it. So this red angle is not quite 180 degrees. It would be with the 37 together. That makes this angle 180 minus 37, which is 143 degrees. So I'll just write that in there. That's this angle. Okay, the angle, that's FDA. What about FDC? There's that. So if I was instead doing this angle, it's bigger, this angle from here all the way to there, well, that's bigger than 180. But how much bigger than 180? Well, because of vertical angles, this is 37 degrees also. So this FTC angle is 180 and then an additional 37, or 180 plus 37, which is 217 degrees. And there's one more angle. It looks almost like an acute angle, but it's FZB, which looks like a nice acute angle, but here I'm talking about the angle that's all the way practically 360 degrees. That angle is not 360 because it doesn't quite make it there. This is 37 also. So this would be 360 if it had the 37, but it doesn't have the 37, so it's 360 minus 37, which is 323 degrees. And those 4 angle measures, 37, 143, 217, and 323 are all related to each other. We say they all have a reference angle of 37 degrees, and I'll explain a little bit more about that in a second. Now, the reference angle is the acute angle, so that we use the Greek symbol alpha as 37 degrees. And when I ask what other angles bigger than 37 have a reference angle of 37, I'm basically asking for those other 3 answers. They're the other angles whose x and y coordinates are the same as the x and y coordinates for point E, except maybe they're negative. I'm going to call those theta. I'll put a little 2 here for the quadrant 2 one. That one can be calculated by doing 180 minus the reference angle. That's where the 143 came from. The quadrant 3 one, which is here, that could be calculated by doing 180 plus the reference angle. And the quadrant 4 one was calculated by doing 360 minus the reference angle. So if you're given a reference angle, you could find the other 3 angles using these three formulas. So this question says, if we're told that cosine 66 equals 0.4, here's 10, 20, 30, 40, 50, so somewhere around there. That's the 66 degree point. And to say cosine 66 equals 0.4 means that the x-coordinate of this point is 0.4, comma. It doesn't even matter what the y-coordinate is. And the question is, what other three angles can you get the cosine of? And the answer is, it has to do with if you reflect that 66 degree point here, or I reflect it over the y-axis, or I reflect it over the origin, I get these 4 points that are kind of in a family where, except for that they might be negative signs involved, their x and y coordinates are the same. These 2 points down here, these 2 points have the same x-coordinate of 0.4. These two have x-coordinates of negative 0.4. These 2 points have the same y-coordinate, whatever it is, and these two have the opposite of that. Well, the other three angles are gotten, like we did before. Basically, this is basically saying what three angles have 66 as their reference angle. So for this angle, it's going to be 180 minus 66, which is 114. For the quadrant 3 one, that's 180 plus 66, which is 246. And for the quadrant 4 one, it's 360 minus 66, which is 294. So that's one thing that you have to be able to do, is given a reference angle, in this case the reference angle was 66, to find those other three angles whose sine and cosine are basically the same number, except that they might be negative sign involved. We can also go in the other direction. If we have a theta given to us, we can figure out what the reference angle that goes with that angle is. And the way this works is, like, here's 160 degrees, this first picture. So the reference angle is the acute angle, which would be kind of over here. It has like, it has like the same y value, but the opposite x value. But finding this angle is a little tricky. But this angle here is actually equivalent to this angle here because it's kind of like reflected. So what you can see here is that the reference angle is also over here, sort of in between this terminal side and the x-axis. And you can see that this angle, this alpha angle, is basically 180 minus the theta angle. So the translation the other way is that alpha is equal to 180 minus theta. I'll stick a little 2 there to say that it's for second quadrant. If my angle is between 180 and 270, like in the second picture, its reference angle is really over here in the first quadrant, but it's kind of hard to work with that one, so instead I'll work with this one over here. And as you can see, that alpha is the whole theta angle minus the 180 to be left with that piece. So alpha, I'll call this theta 3 for third quadrant, minus 180. And there's only one more quadrant it could be, which is the fourth quadrant. And even though that the reference angle is really over here, I'm going to focus instead on this angle, which is also equal to the reference angle. And as you can see, that's basically the whole circle minus the theta angle, so it's 360 minus, I'll call that alpha, or theta 4. So these are sort of going in the other direction. There is a visual way to look at this that's kind of even easier, which is how many degrees do I need to go to get to the x-axis? Like here I'm at 160, so if I go this way, I just need to go 20 degrees. That's the reference angle. In this one, I'm at 230. I need to go backwards 50 degrees to get to the x-axis. For these, I'm going to the sort of negative side of the x-axis. And on this one, I'm at 320. I need to go 40 more degrees to get to the x-axis. So you could think of it as how far am I from the x-axis. That's going to be your reference angle. A type of question you can do with this finding reference angle thing is if I need to calculate out, or if I need to know the value of sine 158. 158 is somewhere, here's 180, 170, somewhere over here. We can say, well, one thing about sine 158 is that it is the y-coordinate of this point, which is positive. And we're going to relate it to a reference angle, so it's going to be the same y-coordinate as sine of the reference angle. Well, the reference angle is really kind of over here. We have a formula for it, where the reference angle is 180 minus quadrant, if the angle is quadrant 2 angle, we do 180 minus that. So I end up with positive sine 22. And we leave the answer like that for now. This question is asking us about sine 202. So 202 degrees is somewhere over here. So we got this big angle. So first we could determine that sine of 202 is negative because the y-coordinate of this point is definitely negative. And then we just write sine. And now we just put the reference angle. Now 202 has passed the x-axis, so I need to go back 22 degrees to get to the x-axis, to the 180 point. So that one we write as negative sine 22. For sine of 338, actually I'll skip that one. I'll move on to the cosine example, then I'll be done with this video. So this one's asking about cosine of 128. 128, here's 90, 100, 110, 120, so it's somewhere over here. So cosine of 128 is definitely negative because now we're talking x-coordinate. And it's related to some reference angle. The reference angle is over here somewhere. That's the reference angle. But it's easier to find the reference angle by looking at this. How far away am I from the x-axis? So to do that, I do 180 minus 128, which is 52. So we say negative cosine 52. Now, if I have a trig chart that tells me the value of cosine 52, or the sine and cosine of angles between 0 and 90, I can then use this type of analysis to find the sine and cosine of angles that are bigger than 90.